This lesson is about congruent transformations. It's the introductory lesson to Unit 4. Congruent. Congruent is when figures are exactly equal in size and shape. By size and shape, we are referring to both the side lengths and the angles. Figures that can be placed one on top of another using one or more isometries. So a congruent transformation is the composition of transformation that places congruent figures one on top of the other. So the idea is that if we can take a congruent transformation that includes a, whoops, let me get my pen here, a translation, or a reflection, or a, what's the other one? Rotation. So if you can use a translation, a reflection, or a rotation to take one figure and map it onto the other, then you have a congruent transformation. And if you can do that, then you know you have congruent figures because they will be equal in both size and shape, regarding side lengths and angles. So I've got two examples for you. One of them deals with figure OPAL, and the other one deals with figure ROSE. So the idea is that if we can take shape OPAL, and I know there's no letters down here on this blue one, and I kind of did it on purpose so that you're not just matching up letters to letters, but you kind of have to think about manipulating the shape in your brain a little bit to see what it's going to match to. But if you can take OPAL and match it down here onto this blue one, then they'll be congruent. And if the answer is yes, you can match them on top of each other, then I want you to write me the transformation rule. If the answer is no, then explain why. So take this four-sided figure, opal, and you're going to try to get it onto this blue one down in the lower left-hand corner. So what kind of things can you do? We've got translations, we have rotations, and we have reflections. Dilation isn't going to work here because dilation is going to change the size and shape, well, mainly the size, making it so that it's not congruent. So thinking to ourselves, we have these as our options. We can take a translation, a reflection, and a rotation. As I look at the short side here, I've noticed that it's changed positions to get down over here, so I think a rotation is happening. What I'm going to do is to check to see what kind of rotation there is. We have rotations of 90, 180, and 270. So I'm going to turn my paper. What I did too, for sake of kind of a visual, is I have this blue shape down here, and see that little lock? It's locked in place. So I'm going to turn my figure until I can get it to be in a corresponding position. So I'm going to go 90 degrees. Remember, that's counterclockwise. So watch OPAL, still not in the right place yet. I'm going to go 90 more, which takes it 180, and it's down in the right quadrant, but it's not oriented the right way. So I'm going to go one more 90 degree, which takes me to 270. And what I notice, whoops, is that the shapes are now in the same orientation. Think about it being down here, but they're not in the same position. So plot your ordered pair, write down your ordered pairs. Let me get my pen here. And I'm looking, and I'm going to have O prime at 6, 2, and P prime is going to be at 8, 6, and A prime is going to be at 7, 7, 7, negative 7. I forgot all my negatives here, didn't I? And L prime is going to be at 4, negative 4. So take your graph, take your paper, rotate it back around, and you should have where you left it. So I have this green shape that is at 6, negative 2, 4, negative 4, 8, negative 6, and 7, negative 7. It's at least oriented the right way, so I know I had a rotation of 270 degrees. But now we've got to figure out how to get the green shape on top of the blue shape. And I see that a translation is occurring. So reflection's the one not used here. I have to take that green shape and from where it's located, move it 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm moving it 9 spaces left. Actually, I take that back. It's not 9 left. 9, 10, 11 left, and 2 down in order to get this corner to match up with this corner. So it appears that yes, the figures are congruent. How do I know they're congruent? I know they're congruent because I took the original figure, which was OPAL. I rotated it 270 degrees about the origin, and then I translated it 11 to the left, oops, I'm running out of room, and 2 down. So these shapes are congruent because I was able to take one shape and map it onto the other by a series of congruent transformations. All right, here's the next one. I have quadrilateral ROS, and I want to try to map it onto this blue one over here. A lot of you are looking at this shape, and you've probably realized that this length is 1, 2, 3, 4, and this length is 1, 2, 3. So no, these shapes aren't going to be congruent for the main fact that they're different sizes, they have different lengths, but I want to show you what that would mean for transformations anyway, just in case you didn't see it. So if you think about the idea of rotations, reflections, and translations, what would have allowed you to orient ROS the same way as that blue one down there? I'm seeing a rotation because this short side needs to match up with this short side. So I, again, for visual sake, locked this blue one in place so that I could turn my paper and kind of show you something. So if you were to take your paper and turn it 90 degrees, 90 degrees, and then one more 90-degree turn, what I'm noticing, what I'm noticing is that at least they're now oriented the right direction because this short side, this OS side, is going to match up down here. So I saw that I took ROSE and I rotated it. I did two 90-degree turns, so it was 180 degrees about the origin. Now I recognize that there's going to need to be a translation of some sort. So think about taking the shape as it is here, and you're going to need to move it down and over. Well, how many down and over did you take it? I took it down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and left 1. But when I did that, look at the shapes. The original blue shape that I needed to map it onto doesn't match the green shape, this ROSE shape. So even though I was able to write a translation rule or transformation rule, because the two don't map onto each other perfectly, they're not congruent in both size and shape. These triangles are not congruent. Again, the idea there is that they are not equal in both size and shape. The reason behind that is that no transformation maps one onto the other. So that's all I have for you. Only 2 examples. I figured we just got done doing things with congruent transformations, or with transformations. So congruent transformations has just actually taken away your dilations. So there's only 3 now to work with instead of the 4. But summary, if you can take a shape and slide it, or flip it, or rotate it, or any combination of those 3, onto another shape, then those shapes are congruent in both size and shape. That's it. Thanks so much. Let me know if you have any questions.